So despite what we have just said, that AI can make mistakes, there's no doubt that generative AI is extremely good at coding. There is a website called Live Code Bench where they maintain a leaderboard of some of the latest generative AI models. I'm recording this video in early 2025, and at this particular point in time, one of the most powerful generative AI models, OpenAI's O3, is not yet available to the researchers who lead the Live Code Bench effort. Nevertheless, they have examined the performance of some of the O1 models in some of the newer models like DeepSeek that have proved extremely effective. At Live Code Bench, they examined the performance of these models on easy, medium, and hard problems, all of which are drawn from recent coding contests. Many students enjoy participating in coding contests. And as we shall see, some of these problems, even the easy ones, are really not very easy for beginners like us. I'll give you a quick example right here. I have deliberately hidden some of the details of this question because really they're not relevant. There's something about a boy going for a birthday, but the key parts of the problem are highlighted here. We're given an array of n digits. As we shall see, an array is simply a sequence of digits. And what we need to do is we need to basically calculate the product of all those digits. Well, that seems easy, but there's a little bit of a twist. We want to calculate the product of the digits, but before doing that, we get to add 1 to any one of the digits. So for example, if one of the digits is 5, we get to change it to a 6. If one of the digits is 9, we get to change that to a 10. But we can only do this for one of the digits. And now the question says, what should we do to maximize the product? This is an example of one of the easy problems. And as we can see from these graphs, the modern models perform at almost 100% on easy problems. There are more challenging problems, the medium and the hard, and there the performance of these models starts dropping off. So these models certainly can solve problems very effectively if they are easy. If the problems are not easy, then if a human can decompose these complex problems into simpler ones, then we can rely on these models to solve the easier problems very, very effectively. Just to go back to this problem, if you think about it, it might not be obvious what the algorithm is for solving this problem. Here's an example that might help us think about the problem a little bit more concretely. Suppose we give these numbers to you, this sequence of numbers. Remember, you get to multiply these, but before multiplying them, you can increase one of the numbers by 1. The answer for this is 432, and this particular answer is obtained by increasing the 2 to a 3 before multiplying this out. So I'd like you to think about what algorithm might work for this problem. When we say that these models can solve easy problems like this perfectly, they are taking this particular problem statement, working out the algorithm, and then translating that into code. That is impressive that they can do this with almost perfect accuracy. So let's test our understanding. I'm going to give you an algorithm for this task. And to show you how this algorithm works, I've also illustrated how it works on the same example that we saw on the previous slide. So we give you as an input a sequence of digits. Let's call those A1, A2 up to AN, right? For example, these 5 digits. Now, the algorithm that is suggested is the following. Firstly, figure out which digits are unique. You can see that 4 appears twice and 3 appears twice, but the unique digits are just 2, 3, and 4. Now, sort these digits in descending order. So we'll end up with 4, 3, and 2 on this particular example. Now, glue these together into a single integer 432. I hope you're thinking critically. You might be wondering, hey, wait a minute, is this a standard basic step? And the answer is yes, we can concatenate individual digits into one. In many programming languages, including Python, this is a very basic step, which we will see how to do. Finally, output that number. So in this case, we will output 432, which, as we saw, was the correct answer. So, is this algorithm correct? Think about it.